Hey, I'm having a great time. So my name's Cameron Maerz, and these are my findings to date. I am a securities researcher and penetration tester. If you want, I'm on Twitter at PonesForCash, and my blog, cantankerouscomputing.blogspot.com. A highly respected colleague informed me network security was dead. This was near the time certain hotspots started to pop up around me. In my research, I discovered how to bypass WPA2 authentication, allowing an unauthenticated access to an otherwise secured network area. This is my home. This is your home. I've ethically disclosed this information. And some of the stuff, it dates back multiple years. These issues, however, they've been identified in several more devices, spanning the service providers which make up the Cable Wi-Fi Alliance. Today's talk will cover several routers in said networking environments, along with misconfigurations pointed out and given to the providers. Oops. Let's go over some jargon real quick. So the CPE is the customer premise equipment. This is your wireless router that's combined with your modem that's allowing signal to come in and out. And this is a DOCSIS device, actually DOCSIS 3. And DOCSIS is data over cable service. And or data over cable service interface specifications. And what happens is this device, the DOCSIS device, communicates to a border router slash cable management terminal station. And this is the head-end equipment in this network environment. And because it is a DOCSIS device, that means that in their networking environment, it supports voice over internet protocol. To initialize this protocol, there's a session initiation protocol. They also have MoCA, which is multimedia over coaxial alliance. And that's able to provide you with DLNA, which is digital living network area. And that's able to be provided to you because of MPLS or multi-protocol label switching. And that's coming in on a hybrid fiber coaxial network. And in that networking area, it's a dual stack environment, meaning it supports both IPv4 and IPv6 at the head end. And network address translation, or NAT, is a table which stores internal routing information to the wide area network, or WAN. And the LAN is the local area network. This is your devices that are inside. And the virtual LAN would be similar to the WLAN, which is a wireless local area network. And that's able to be provided by a virtual interface of the LAN, aka VLAN. And PMP is port, excuse me, port managing protocol. These are the members of the Cable Wi-Fi Alliance. And yes, this makes up almost the entire country. What? What the hell?
Check your back out. Check your video setting, your system. Pull it back out.
All right, we'll see if we can skip back and see what happens. Okay, so Are we good? All right. The Wireless Broadband Alliance's Interoperability Compliance Program, or ICP, provides a set of Wi-Fi guidelines for mobile operators to standardize the way that my video just... No. It does not like me. Back up again. All right. And it's out again. Okay. All right. I unplugged and replugged. Let's see. Mobile operators to standardize the way devices connect and roam on Wi-Fi networks are known as WISP-R. Wireless Internet Service Provider Roaming. WISPR allows users to roam between wireless internet service providers in a fashion similar to that allows cell phone users to roam between carriers. A radius server is being used to authenticate the subscriber's credentials. WISPR 2.0 specs were published by the Broadband Alliance of March 2010. This is just a picture of the login into my gateway, which doesn't have any SSL. It's not good. Well, they are self-signed. See? And the mystery begins to unravel here. Not only can you see these are self-signed certificates, the individual, or as indicated by the MAC address on the left-hand, well, yeah, your left-hand side browser window. That's right over there. You can see CC03FA. Another IP address is also able to be routed into the device to the residential administration console. That's weird. Why would another IP address route into my administration panel? So some things just feel fishy. I decided to jab it with a stick and see what happens. So the Technicolor model TC8717C, it can't handle my speed tier. It was 105 I was getting or paying for, but I only ever saw 70 down with it. And it was replaced due to a hotspot issue. They didn't say exactly what this hotspot issue was. They just said I had one, and I had to have a new one. Oh well. The Maerz TG862, I was able to bypass the portal twice. And the Technicolor 8030C was able to route into the VLAN from the hotspot. Having a predictable media access control identifier and MAC number in any networking scenario is of poor practice, none more so in areas where VLANs are present. This issue was privately disclosed some months prior to June 2014, some of which became public domain as of September that year. I keep getting referred to the AUP, or Acceptable Use Policy. Thank you. In the process of assigning the virtual LAN's MAC, completely randomize its new address, making it much more difficult to guess. In this screenshot, I'm simply wirelessly monitoring my home. Why am I powering a radio I cannot control? What's it do? Is this offloading traffic for their partner's mobile network via the hidden ESSID? The providers didn't tell me about the hotspot. I wonder what trickery is beneath this. What can you take away from this? Well, what you can take away from this is learning more about the devices and how they assign MAC addresses. Because as you can see on the left-hand side, these are just incremented by 1. For each VLAN it's going to put up, it's only going to be 1 more. Well, subtract 1. Where does that take you? Why is the radio, which I cannot control, in my ARP cache? Weird. Because of device behavior, we can test for fault tolerance, which cause the device to initiate packet sequence. Keep this in mind as we move throughout the slides. In my research, I was exploring inter-device relationships. I came across this old patent and ran with it. I thought a router routes packets to a switch. The switch switches packet to a bridge or trunk, which finally goes to a port. Yet, in this patent, the protocol and the devices supporting it are doing the switch's job. The router communicates on OSI layer 3, while the switch is at layer 2. Where's the switch in this diagram? There's not one. It's software defined. I can see the router, I can see the bridge, I can see the ports. Where's my switch? Do you really need this if you can make the decision on yourself? This is simply a slide to help visualize the traffic flow through this device. I'm not calling out any names or anything, it's just to visualize how the traffic flows. Originally using the tap-tone interface, the hotspots were able to be bypassed, allowing a route into the residential VLAN from the hotspots VLAN. I wanted to keep going though, as I felt more could be done. Having knowledge about their mobile partnership, I decided to research the differences between regular connected devices and mobile devices using LTE over Wi-Fi. Again, I was able to route into the residential VLAN via PMIP, harnessing GRE tunnels with internally addressed bridges. If these devices had the proper ingress and egress filters in place to begin with, this nonsense wouldn't be applicable. You could gain unauthorized web content via DNS tunneling. You could also create denial of service conditions, which allowed you to bypass authentication. I had noticed when connecting to the hotspots via SSL, or an SSL connection was formed. Knowing that SSL is far slower than TLS, I decided to test for exhaustion conditions. The server responds with much more data than our initial hello, as seen in this slide. The exchange started when a new MAC address was introduced. I decided to use MACoff, and that's a tool in the DSNF suite, and it resulted in the CPE completely shutting down for a period longer than 5 minutes. Because of the predictable MAC, combined with shit filters, you can also ping your EMTA or embedded multimedia terminal adapter. This is what connects your phone to your router. In this slide, I'm simply showing or displaying the ARP entries, making the appropriate subtraction and resolving its address by using ARPing. It's a utility allowing for the discovery of active IPs on your network. I wanted to view the CPE from as many vantage points as possible. This is a fingerprint of the route to my home SIP address. And yeah, it's changed. But that's kind of funky. SVMap is a network scanner for SIP, and it's fast, light, and it also gives a pretty good fingerprint. Curiosity pushed me to really dig into discovery. I wanted to learn more, and I wanted to do more. And I wanted to ensure the security of my home, in your home, in America's homes. Don't we deserve better? I'm not implying the provider is vulnerable to any attack by any of these methods. I'm simply stating the possibilities. Remember that 172.16.12.1, which resolved from earlier? Its response is a redirect to 0.0.0.0. Why is this going on in my house? Trying to figure out why this was led to the fingerprinting. This is a screenshot of the spectrum analyzer. It's used to measure RF signal in a network. This screenshot shows a misconfiguration when handling the user agent. When a request was sent via Iceweasel, it displayed this. But yet, in Chrome, it was rendered. Initially, I had thought this might have been HAP1, which is the Home Administration Protocol. That's typical of a DSL network, but I'm not in one. However, it still might be. I've been wrong before. But I'm fairly certain this is a port mapping issue. This misconfiguration is in the ARIS-TG 862 and the Technicolor TC 835C. This is a firmware issue, but the Alliance is sharing the goods. So the same issue is also present in the UBDDW365 offered by Time Warner. Using a technique known as verb tampering, you can trigger a login by using a put instead of a GET request. However, due to port mapping rules, you are unable to access the administration panel. For the longest time, I thought I had the wrong password. I tried and tried and tried and tried. Just using ping though, weird. What is this? How does something get translated from .70 to .2? Must be a port mapping issue. This shows that, well, yeah, it's beyond just my home. See, before it was 10.0.0.2, and now we're at 10.0.0.5. It's not just my home. This isn't using the tap-ton interface. This is as an unauthenticated user joining any wireless network that it's attached to one of these CPEs that also supports DOCSIS VoIP. If you don't have the home phone, I don't think it'll work, but it might. Reciprocate, it's cool. And it's also the proxy that's handling your SIP information. As you can see here, I am connected to Wi-Fi hotspot. Awesome. I'm also showing that there is no funky tunnels going on. Awesome. Yep, down, 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 down. And I just continue to show that we're down. I don't have any tunnels going on. I don't have any tap interfaces going on. No mischief is going on. It's just, you're there. Admin. Yeah, default login creds right there. Okay, so what? I don't know. I want to play with it though, right? Here you can see I'm displaying IPv6 addresses. Ooh, that's cool. But wait, what was that? Add a user? Okay, I will. Don't mind if I do. And I've discovered that the device is also vulnerable to stored XSS. That's bad. And then I have all of the internal information. That's bad. That's really not good. Login type, syslog. What's this? Yeah, it's bad. Bad, 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 bad. Highlighted in blue, you can see the public statement regarding their architectures. I will 100% confirm that they are very much using Eris head-ins for their CMTSs. A CMTS is like a DSLAM in a digital network or digital subscriber line access multiplexer. If you had to, think of something to compare it to, this is simply showing the route of what's marked as the CPE would be your home computer, which connects to the cable modem, and then you can see the flow of traffic going around. It's really fancy. Now, I want you to look at these MAC addresses. This is really important. This is tap 1, or 0, 1, 2, 3, yada, yada, yada. They're all tap interfaces, courtesy of libvirt, Mac vTap. And they're just building one at a time, one number at a time. And where am I going with this? This is a big deal. This is a severe misconfiguration. Because there's your cadence CMTS. Now I'm ARPing outside of my LAN. Now I have your head-end equipment in my LAN. I've just pulled your equipment in my LAN because of whatever issues you're having. I don't know what's going on. I suspect it's ingress and egress filters. You can see here I'm using the ARPing utility as misspelled to resolve the first hop, which would be the CMTS. And then go back over to the packet capture. Boom. All those replies. That's bad. The ability, Braden Thomas, who spoke at Infiltrate, was the best of my knowledge, the most recent person to speak with any provenance on this matter. Well, how far upstream? Via which channel? I know this is just one hop outside my, my network on the node, but it's a start. Where do you want to go? According to online publications from the cable provider, the information is passed through tunnels, kind of like a VPN. I'll keep that in mind in case you didn't read the note I left on VPN eavesdropping. Is that a fact? I mean, seriously. And let's see. Oh, 10.0.0.1 to 192.168. Yeah, dude, what? Bored right through it. This is a screenshot using dsniff, having exploited the initial misconfiguration. Sure, the exact script sure, I'm going to toss out a script. The exact script used to initially cause said errors. I'm going to put on my blog tonight. I'll have it up there for y'all to have at it. Hey, you guys want to go around and kill hotspots? Luckily, that issue has been resolved, but you'll see in the upcoming slides how you can go about rediscovering this information for yourselves. And connected to the hotspot, what would be returned if an internally routed traceroute was performed? I would expect everything to drop. However, this was my output. The device is interpreting things wrong. You can assign an internal MAC address of the equipment to the tap interface. Once configured to send multicast multicast and ARP, it forces the CPE to reveal an otherwise unknown address. This, combined with the appropriate routing rules, may allow you to access otherwise unknown networking areas. And what we can see here is, what are we looking at? All right. Yeah, this is the radio's MAC. The actual radio's MAC address is not supposed to actually be out. And I want to go ahead and plug this in just because it's been sitting up here and I wanted everyone to see this. No shenanigans are going on. I'm going to go ahead and plug this in now because it takes it about 5 minutes to boot up. And then I'll show you the ultimate fail. On our next slide, we can then see the residential VLAN. That's bad, real bad. That was a hotspot, and although I wasn't able to reroute things, I did get their speed tier, and you can look at the date. Ozala. But seriously. Yeah, right? Okay, I'm going to go ahead and back out of here and why up on that? Now I'm going to have to flip the displays around. I appreciate your patience. Yay, all right. Sorry about that. Let's see if she's up. Well, looks like she's up. What's really interesting about this, no, you can't see my screen. Okay, hold on. All right. Stumbling, fumbling, bumbling. All right. Good. Okay, we'll go ahead and connect to Xfinity Wi-Fi. And this is going to fail. Why is this going to fail? This is important. Why is this going to fail? Exactly. Exactly right. So by not having any extra upstream signal, this device is going to fail. What's going to happen when it fails? What's the default status of a failure in this device? Huh. It's a switch. Come on. Exactly. Right on, right on. So you can see that we're still trying to connect to it. And it will fail. Eventually. Oh, now reconnects. Please excuse me. I am connected. To the Western Conference. Oh, that's not good. Let's see. Edit connections, wireless, Western Conference, delete that. Delete that. All right, fail. Come on, fail. But another thing is, so if you're thinking about this tap interface, what's going on? If you pull one of these up, it kind of causes a denial of service on the socket level. And it's kind of cool because it's bringing in a denial of service in a different light than one normally perceives it. People think of these giant denial of services, but it only has to be for long. And by that amount of time, you can gain arbitrary route information into a restricted area. Why? Well, switches fail open. That's our default tolerances that we need to test. If we can trigger that in a mechanism, we can capitalize on that behavior. If we can think of people and how people program things and are at a mass, we can also put that down into micro size because we program our electronics. Thus, our electronics inherit those behaviors. Now fail. Please. It's trying. Yep, there it goes. Now where are you going? Yeah.
So if you can arc into the heading, you could potentially, theoretically, spoof the doctor's permission for
Indeed. Yeah, and thus stealing their bandwidth. Correct. Denial of service. Oh, well, in the RF network, I mean, just the spectrum analyzer itself, you can then increase your signal then. It's the demo gods. Oh no.
Really, the only thing to do is
Is the what? Well, hopefully, the providers are going to get on the ball, and you know.
That's the thing, right? So I can put a firewall in front of that. Okay? I can just not use that Wi-Fi, but I can't prevent someone from not using my upstream, hacking the CMTS, gateway, whatever it's called, and then re-provisioning my modem.
Well, you know, this really funny thing.
I mean, that does stop them from coming into my network,
Right.
But it doesn't stop my upstream.
Yeah. You can also gain the MAC address of the CPE via the headers on some requests in the website, because when you go to authenticate, it's going to ask you to type in your password. And when you go to do that, it's going to have a MAC address in there. And you can also spoof. Well, yeah. But it looks like I'm going to die due to the demo. And yeah, so I'm going to go ahead and flash my last slide. And oh, really? Oh. That's cute. Okay, there you go. I just want to thank you guys for showing up. I want to thank everybody who helped sponsor this event, and I really wanted to thank Belt and Asobi and Glitch and everyone who's helped me out. It's been absolutely amazing.
I've got a question. If you disclosed this last year at CircleCityCon, why do you think Comcast hasn't addressed it?
It's not that they haven't addressed it, it hasn't been addressed properly. As I was saying, by having a pragmatic or programmable, being able to predict that MAC address is very bad. And the fact that I can initiate that.
So they band-aided it with the Mac.
I'm not going to say with the Mac. They've band-aided it. Yes, it's just been like offset to another device ID, and all you really have to do is just roll through it, and it'll puke it back out for you. Assign it, put your routing information up, wham. As I said, I'll be putting a script out. If you guys want to test it, go nuts, have fun. All right, thank you so much.